So you see, we're looking at the steps, right? So I was explaining is that you put the screw pin and the riser pin, and then you put the molding sand, right? So that you have these cavities also, right? We can remove this, right? When we put the molding sand and rammed it, we'll remove these riser pin and screw pin also, just as we have removed the pattern, right? So that we'll have that cavity there, right? And the molten metal can come there also in the riser and through the screw pin to the pattern, right? That's what happens, right? Through the screw, it reaches the pattern and then it climbs up this riser, as the name suggests, riser. So that is what is explained here. Okay, and this facing sand is also sprinkled, right, all around the pattern so that the pattern does not stick, as we have seen in that video. To avoid the pattern sticking to the molding sand, you put that facing sand. That is one type of sand that doesn't allow the pattern to stick to the molding sand, right? Adhesiveness is what is what do you call obstructed by doing so. So then the drag is filled with loose prepared molding sand, and then ramming is done uniformly. Fill the molding sand once again, and then perform ramming. Right? Repeat the process 3-4 times, so that you can have a sound mold, right? So once you have poured the sand, you ram it, and then it decreases in volume, right? It gets compact. So then you add some more sand to fill that emptiness, right? So that is why it is said repeat the process 3-4 times. Once you feel that there is enough sand and you have achieved the required permeability or density of the sand, right? As is required. So the excess amount of sand is then removed using stripe of bar. Should we look at the video again? I'll put that video in the group, okay, hopefully. So you can have a look at it again. So you'll remove that using the stripe of bar to bring the molding sand at the same level of the molding class, right? To complete the drag. The drag is then rolled over and the parting sand is sprinkled over on the top of the drag, right? So that you can have that separation easily. One of the co-pattern is placed and alignment is done using dowel pins, right? Alignment pins. Then cope is placed over the ram drag and the parting sand is sprinkled all around the cope pattern. Okay. Right, you see, aligning pins, and this is the parting line where the cope and drag are meeting. Okay, anything else? Right, that's what we saw. And then I told you to put the screw and riser pins in that top portion, right, where we are going to pour the molten metal from, like for example here. So this should have the pouring basin and riser provisions. So that will keep, it will have to form suitable sized cavities for pouring molten metal, right? As I said, you want to form the cavities just as you have formed mold cavity for the pattern, you want to form cavities for screw and riser. So, and there's something called chillers, we'll see. Okay, what is a chiller? Basically, let me explain it. Chillers are kept, okay, near this mold cavity, right, so that you can have a faster solidification. Those chills are responsible for taking the heat from the molten metal, right? There is a heat transfer, isn't it, from the molten metal to the molding sand. So wherever you have placed chillers, right, near the that mold cavity, more heat would be absorbed by the that chiller, right? I hope you call it chills, okay? I'll confirm. So those are responsible for taking all the heat, right? So that directional solidification is achieved. That is one important reason why chills are kept, okay? That you have directional solidification. If I want more heat right? What do you call more absorption of heat, right? Here, then I will place a chill here. So this will absorb the heat, and the direction of the solidification direction is like this. It will solidify here and then there. Directional solidification is achieved using chills. Okay. So, and then strip off the excess sand from the top of the cope also, just as you have done with the drag, and then remove the screw and riser pins. So then you have the cavities, and you have to create the vent holes also, right? As you have seen in that video, just so you have more escape of those gases. Okay, not just from the molding sand, right? As we have discussed, but even to have more escapement of those gases, you are creating special holes called vent holes. So it can easily go from those vent holes. The gases can escape. Basic purpose of vent creating wells is to permit, as I said, right, escape of gases. Sprinkle parting sand over the top of the cope surface and roll over the cope on the bottom board. So for easy removal, right, later. Wrap and remove both the cope and drag patterns and repair the mold suitably if needed, and dressing is applied, right? So that wrapping is done if at all needed, so that you don't have removal of those when you're pouring the mold in the middle. The gate is then cut, connecting the lower basin of the screw basin with runner and then the mold cavity, and then the mold coating with a swab. Bake the mold in case of a dry sand mold. So if you are looking for a dry sand mold, that the moisture has to be removed, and therefore you have to bake it. Set the codes if needed, right? If there are internal features, then you have to set the codes if needed, and close the mold by inverting cope over the trap. Right? The cope is then clamped, and the mold is ready for pouring. Right? After the clamping is done, it is ready for pouring the mold in the middle. Right? What we have discussed there. Starting with the drag pattern, filling the sand, ramming it, putting more sand, and then again ramming 3-4 times, just so you achieve that required density and permeability, etc. And then you put it upside down, remove the drag pattern. You do the same thing with the cope pattern. And extra thing is your riser and screw pin. And then you remove that riser pin and screw pin once you have put in the molding sand, right? So you have the cavity for riser and screw pin and the gating system. And then you align it with the align pins, and then you can put the mold in the middle, right? Once it is clamped, right? You see here, this is what we want. You see here required casting. You have a hole here, as you can see, dotted lines. The hole is going through this component. So to produce that, you're making this, you're putting this core, right? So that core is put. This core print is basically to seat, for the core to have a proper seating, right? You see here, for it to be intact, you're providing those core prints. Even though you want a straight hole here, this extra thing is called core print, wherein the core will sit, seating of the core into this molding sand. I'm sorry, into this core portion of the pattern and drag portion, right? So you'll put this pattern, right? You'll put the core also along with this core prints, right? Same thing, riser pin, screw pin. You will put that, and then you will remove it once the sand is rammed, and then remove the pattern. So you have the mold cavity, right? The gating system, etc. And then the last thing is this: you put the core, and then you can put in the molten metal, so it will not occupy this core space. So you can get this final casting. Actually, what we get is this: the riser and runner, etc. You will remove it, knock it out, basically, as per this diagram. So you have this required cast. Is it clear? Now core and core making. Okay. You see, we require codes, right? And so how do you make those codes, etc. is what we'll see. Cores are compact mass of core sand, right? The special sand is there, which is used to make those cores. Prepared separately, that when placed in molding cavity at required location with proper alignment, does not allow the molten metal to occupy space for solidification, isn't it? And hence help to produce hollowness in the casting. As I said, internal features when are required, you'll use the core. The environment in which the core is placed is much different from that of the mold. In fact, the core has to withstand the severe action of hot metal which completely surrounds it. Isn't it? Because you see, the molten metal will will uh, will touch this molding sand only on the surface, right? For example, this portion of the molding sand, the molten metal will come into contact only here, right? But for the core, you see, it is completely submerged into molten metal, isn't it? All through, all around it. So that is what makes it more important, and that's why we are saying the environment in which the core is placed is much different from that of the mold. In fact, the core has to withstand the severe action of hot metal which completely surrounds it. I hope the point is clear. Then we have this type of green sand core and dry sand core, right? Therefore, the core must be the following functions. It should produce hollowness, right? The first objective in the form of internal cavities should be sufficiently permeable to allow the easy escape of gases during pouring and solidification. Right? For example, if this setup was like this, rotated 90 degrees, rotated 90 degrees, right? And see it like this, right? So if the gases are to escape, they are to escape like this, isn't it? So this core is coming in between. This part of the molten metal wants to escape. The gases here wants to escape, but the core is in between. So it has to allow those gases to go through. So that's what is also required by the core, not just the molding sand, the core also. So that, and it forms a part of green sand mold. It may form a part of green sand mold. May be deployed to improve wood surface. It may provide external undercut features in plastic. Right? If at all required, I told you some features will be left out, right? Because they are difficult to achieve in casting, and then will be later machined, etc. It may be inserted to achieve deep recesses in the casting. Okay, may be used to strengthen the mold also, right? Certain point of the time when there is too much what do you call mold that is overhanging, then it may be even used to strengthen. It may be used to form gating system of large size mold also. Okay, we'll see code side in the next class, hopefully. If there are any doubts, please ask. Otherwise, we'll end the meeting. Okay, then we'll end the meeting. I've already taken the attendance, okay, in between. As I said, I'm randomly taking the attendance. So we can end this meeting. Thank you.